All right, in example 2, this is actually a rather quick example. Don't get confused by the picture. It's there to show you what's happening visually, but all you need to know is what happens whenever a changes. It asks, for each given value of a, how do the graphs of y equals 1 over x and y equals a over x compare? What is the effect of a on the graph? So we're just comparing 1 over x and a over x, meaning that if a equals 6, we're comparing 1 over x to 6 over x. So in this case, if we look at this line right here, I've drawn an arrow to it, we are comparing that to the original, the parent function, which is this red one right here. So we want to know how those two graphs are related whenever we change the a value. Notice that here, whenever x equals 1, y equals 1. And in this graph, you can't see it because whenever x equals 1, it's actually off the graph. But it's up here at approximately 6. Actually, it's exactly 6. And if we move here to whenever x equals 2, y equals 1/2. Here, we're at a value of y equals 3 on that graph. You may not realize that, but that's just multiplying 1/2 by 6 and gives you a value of 3. So we're just multiplying all of our y values by 6 everywhere on this graph. So whenever a equals 6, we're actually stretching our graph by a factor of 6. So we're stretching y equals 1 over x by a factor of 6. We know that we're stretching because if you look back at your table, 6 is greater than 1, and therefore it's going to be a stretch. Let's look at b, where a equals 0.25. 0.25 is between 0 and 1, and says that we're going to have a shrink by that factor, according to the table above. We can see that because here's the line that we're looking at on this one. You see how it's actually lower and closer to that 0? That's because we're actually shrinking it. So here we're going to shrink y equals 1 over x by a factor of 0.25. And c, whenever a is equal to -6, well, we know what happens whenever a equals 6. We're stretching it by a factor of 6. But here we have that negative in front of it. And if we think back to the table on the front, it told us that if a is less than 1, or less than 0, meaning that it's negative, we're going to be reflecting that over the x-axis. And you can see that visually right here because this line is across the x-axis versus the previous ones. So here, two things are happening. First off, we're stretching y equals 1 over x by a factor of 6, and reflecting over the x-axis. So both things are happening, and we want to take account of both of them.